You there? There we go. That should be working now. Tell me if the mic and everything's working. Hey guys, welcome back to the channel. Yeah, sounds all good. We're back. Let me just make sure my door's shut. I was just getting my drink of water in the same glass as the last 3 days. We've got a exciting little lesson today. No. Yeah, exciting little lesson. It should be shorter than the other lessons we've done so far. Okay? The best part of the day has begun. I agree. Yes, I washed the glass. Don't you worry. So, before we start anything, I just want to cover a couple notices very quickly. Firstly, the common assessment. Let me show you the common assessment. So there's a common assessment that Mr. Subramani has posted onto Google Classroom. You can see here. I've reposted it as a PDF because there was some comments saying it doesn't work. It only doesn't work because it's a Word document, right? So I just upload it as a PDF. You can see it here. It's out of 45, so it's marked out of 45, and you can see the point values of everything. Okay, this is the assignment I want you guys to start basically this weekend or start on Monday, right? Because the assignment myself and Mr. Maraji have set you was meant to be due on Monday, and then we were going to give you this to go away and do over the holidays. So if you want to work on the other assignment and then start this one on Monday, that's fine. But this assignment is the more important one because it's a common assignment across all of Year 13 Calc. Okay, so everyone, every Calc class is doing this, and it will be marked. It's basically replacing the test we normally do at the end of term 1. Okay. We have covered essentially, in my class, we've covered essentially everything except for this thing, locus, right, and De Moivre's theorem. Okay, everything else we've covered. De Moivre's theorem we're going to cover on Monday, so I'll do one last stream on Monday. We'll cover De Moivre's theorem, but you could probably do this based on what we learned today, to be honest. In terms of simplifying, solving using De Moivre's theorem is where we're gonna talk about on Monday. But you could actually do this yourself for sure after today if you just use a bit of knowledge. Is this the email home if NA test? It is the email home if NA test, but I don't know if that's going to be the case anymore. If you get not achieve in this test, in this assignment, yeah, I will definitely email home. If you get less than 6 points, there's something going wrong, right? 6 points, easy. That's 2 points straight away. That's an easy 2 points. I mean, that's kind of easy enough. I'm just looking very quickly. Boom. Oh no, that's. Let me find another easy looking one. Easy. Very easy. I think we even did something very similar to that yesterday. Or maybe we're going to do something very similar to this today, actually. Yeah, we're doing this today. So that's 2, 4, 6 points done. Okay. 11 a.m. is not too early. 11 a.m. is fine. Right, so just to reiterate, this common assignment is the important one that you must do by the first day back. But the other assignment that we've been talking about is the... Oh no, I didn't want to close that. Let's see if I can find it. Let me take you to my Google Classroom for a second. So, if you go to the classwork section, have a look here, please. You can see this, eh? So the common assessment, I've uploaded it onto our Google Classroom as well. Okay, so this is that assessment there. The common assignment, sorry. Okay. This assignment is the one we gave you that was due on Monday. Please still give this a good crack, right? It's important. You've got lots of time, so make sure you can do this. We've covered everything in here. I'm pretty sure we've covered basically everything, except for maybe this question here. And I haven't even looked at this, but There's probably one or two that we haven't covered that we'll cover by Monday. So you should be able to do almost everything here. That golden number question is just, remember question 5 of that last assignment? There was all this written stuff and it wasn't even that hard. The question 2 is like that, I'm pretty sure. I haven't even looked at it, but I'm pretty sure it's like that. I'll be doing this assignment in the weekend, and I might even do this one, but I'll probably do this one over the holidays. Okay, yeah, Mr. Maraji agrees with me. Oh my goodness, I almost spilt my water. So that's just a heads up on the assignment stuff. Is there any confusion about assignments? Are we all on track? We know what we're doing? All you need to know, this assignment, assignment 2, try bash it out by Monday. Common assignment is very important. You do it over the 2-week break or the 4-week isolation and bring it back first day back. On refill, tidily. The water cannot be spilt. Important water. Cool. Just to highlight again, everything I've done on stream is on here under the worked answers. Right, so yesterday's stuff on complex number and polar form, literally everything we did. Remember we started with this. I posted it all on here. How can you not hear me? You should definitely be able to hear me. Everything I did yesterday here. Yeah, I agree with Mr. Maraji. Try and do it as a test first. So this common assignment, you will be better off the more you try to do it without the help of books and things like that. I'm going to do this without looking at any of my notes or anything. Try everything, and then I'll probably go back and just double check I've got everything right or wrong by using my notes and things. Okay. Rishi, just sort out the sound on your end, dude. It's a you issue, not a me problem. Cool. Right, there's the assignments. Yep, exactly. I agree with Mr. Maraji. Do it as a test, then as an assignment. Okay. Oh, my bad. Oh, we're good. Right. Let's get into this. So, I've written here. Oh, my camera! Did you hear the noise it made? It disconnected. I don't know why it's doing that. It's an expensive, nice camera. Okay. Let's get into this. Right. I've written here complex numbers. You see this? I haven't written polar form. I just want to tackle something for a second. Okay? What we have learnt is we've done rectangular form. So rectangular form is a plus bi, and if we multiply two things in rectangular form, a plus bi, we have to do, let me give myself some more room here, we have to do the multiplication like this, just like we're expanding stuff, right? Write a bit bigger, sorry. I'll zoom it in for now, but I'll write bigger, yeah. Okay, so when we do this expansion, we have to do it like this, right? Which is okay, but it can get a little bit tedious and annoying. If you imagine I had to do 3 or 4 sets of brackets, it gets really long. And let's even like make this a bit more official. I'll put this over here. If z1 equals a plus bi, z2 equals c plus di, then z1 times z2 equals this piece here. I need to fix this middle bracket. C plus di. Okay? Right. We've got this here. And now we also know that we can do the division. I'll write bigger. And we know that this division is really annoying because we have to multiply by the conjugate over the conjugate. And we know we can do this, and it's not impossible, but it's no way near as easy as adding and subtracting rectangular form, right? Adding and subtracting, we just add the real, add the imaginary, and it's done. Now, if only we could somehow make this multiplication and division process significantly easier, right? If only some smart person had come up with a way to make this easier. Have a guess. They have, right? If only, right? It's always the same intro. I know, right? We're discovering calculus together. So, let's have a look at this. Multiply and divide polar form. So we have learnt how to convert into polar form, but some of you may have been wondering why, right? Why have we learnt polar form? Why do we have two forms of the same thing? One of the reasons why we have multiple forms of the same number, the same complex number, is to make operations between those two complex numbers easier. So let's have a look at this. Can you see this notation on the left here? I'm going to write it out. I'm going to call this the power of polar. It doesn't sound quite nice that we're saying power of polar form, but the power of polar form. And the power of polar form is as follows. If z1 equals r, let's follow the exact same notation, right? r1 cis theta 1, where r is the modulus and theta is the argument, and z2 equals r2 cis theta 2, then multiplying and dividing is going to be so much easier, right? Let's have a look. I'm going to drop down onto this page. z1 times z2 equals r1 times r2 cis, and the thetas do the addition, right? Now, I'm not going to get into too much of why this is true, okay? It's another one of those things where we accept that we don't know exactly why, but we can still use it. Just like my car, I don't know all the parts about how it works, but I know why. I don't know why. I can use it, right? The why this is true is quite a deep explanation that goes into some series, and I'm going to look into it this weekend just out of pure interest, okay? But we're not really going to go into it in too much info. More importantly is that we know it's true, okay? So let's just Google it, man. I'm sure you could Google it. So, this is true, and we can also say this is true. Cis, oopsies, theta 1 minus theta 2. Okay? Now, listen very carefully. I want you to notice something here. Now, when I first saw this, I noticed that it kind of reminded me of powers. Yeah, the trig top it done later might help. True. Right? This kind of reminded me of power rules. Right? Where, I'm not going to get into this too much, but just for a heads up, if we do, let's say, 2x3 times 4x5, what does this become? This becomes 8x, or let's even go like this. This becomes 2 times 4 x to the 3 plus 5. 8x to the 8. Oh, it's just happened to be 8. Right? Where the numbers in the front do the maths as per normal, and the power does what I call the step down, like one lower layer of maths. Right? The younger brother of multiplication is addition. And the same thing happens with division, right? The younger brother of division is subtraction. Right? And you can sort of see this here, and understanding this is the first step to finding out why this is true. But I use this as a reminder of this rule. Right? When we times two complex numbers in polar form, we add the front and we times the front and add the back. Okay? And we divide the front and minus the back. Okay? If that's not helpful for you, cool. Isaiah said that that's helpful, which is awesome too. But I found that I saw that pattern straight away. Okay? I saw that pattern straight away. But all we need to know is that this is true. You need to believe myself. You need to believe Mr. Maraji when we tell you this definition. And now with this definition, we're going to tackle 6 problems. And then we're done. Right? Big brain facts. Okay? Let's look at these problems. And they shouldn't be hard. You should be able to do some of them already. But honestly, we could be done in literally 15 minutes. It's going to be a short lesson. Okay? Let's have a look at this first one. U and V are complex numbers where U equals 1 cis pi by 6 and V equals 5 cis pi by 4. And we want to know UV, leaving it in polar form. So U times V. Well, let's write it all out. So let's write it out. Cis pi by 6 all times by 5 6 pi by 4. The front does the maths, right? The front is going to times. So I might even put in here. I might make this a 1 cis theta. So we're going to have 5 times 1, which is 5 cis. And the back half, I'm going to do like this. And pi is common between the two, right? It's like we're saying a by 6 plus a by 4. Right? You need to understand that we can do this addition simply by going 1/6 plus 1/4 and leave pi in our answer. So when we do this, this becomes 5 cis 5 pi by 12. And there's our answer. Questions? Lost? Any misunderstandings? Before I carry on with example 2. If you follow it really easy, do example 2 now. It's no harder. Why 5 pi? So our answer, I'm going to let you guys do it for a bit. Okay? So you can see questions 2, 3, and 4 on the screen. I'll answer Hamza's question though. So why 5 pi? Look at this. Our answer on our calculator is 5/12, right? I'm just going to jot down some stuff here. Pi by 6 plus pi by 4, Hamza, is the same thing if you want to go like this. And then when you add that together, you'll get pi times 5/12, which is 5 pi by 12. Didn't see the calculator right in the center screen. All good. Okay. And we double check we've read the question correctly, leaving your answer in polar form. They're happy with that. We're good. Right. Please do the next one. I have my little sip and then I'll start. Remember, you gain so much more out of these tutorials if you are doing the questions. Example 2. 2 cis pi by 4. Q equals 9 cis 3 pi by 7. Oh, Krishnil's here for the first time. We want to find PQ. So we're going to have 2 cis pi by 4. I might even do it like this, right? I know it kind of looks uglier with all these brackets, but 2 times 9 is the 18. I'm going to put it up here. 18 cis, and the last half, or the back part, just does the addition. 3 pi by 7. I know my handwriting's getting small, it's just because I'm running out of room. Right, Daishok size already got it. Someone's going to drop me in 3 weeks? Yeah, you're dreaming, dude. You're dreaming. 1 by 4 plus 3 by 7. 19 over 28. So our final answer is 18 cis 19 pi by 28. We're done. Do we need to convert to degrees? Good question. Let's have a look. Right? We should just refer to the question in terms of how they want to see it, right? So the question says, find PQ, leaving your answer in the form r cis theta. Doesn't say anything about converting to degrees. In fact, we've been given it in pi. We should probably leave it in pi, right? And you'll probably find that radians are used more often than degrees when it comes to complex numbers. Okay? So we should get really familiar with radians for the sake of your understanding of the rest of this external. Yeah, and the chat's agreeing. Right? Maraji says leave it in pi. Jimmy's saying calculate mostly in radians. Calc is in mostly radians. I agree. Right, example 3, you guys should be ahead of us. Right, Rishi is. Good, ma'am. Right, let's speed up a little bit on this one. Cis pi by 5 s equals 2 cis 3 pi by 10. We want to find the product, which is v times s. You can see this pattern, and you should very much get good at this by doing it 50 times. Say 2 cis pi by 5 plus 3 pi by 10, which equals 2 cis 1/5 plus 3/10. You could probably figure that out. It's going to be a half. So we can say pi by 2. All good. Right. Now let's get some letter questions in. Look, we've got 2 more questions, then we're done. Right? And I want to cover one more thing before we go as well. But I told you it's going to be a short one today. Monday will be a bit harder because I'm going to cover the Moivre theorem on Monday. And if I'm really feeling up to it on Tuesday, we might do locus stuff, but we'll sort of see how we go. I'll talk to Mr. Maraji and see what he thinks, whether we should do a locus stream or not. I'll get very bored in isolation if I'm not doing stuff. So I'm either doing this or playing video games. Might as well help you guys learn. 3k squared cis. Now, my advice is to pay attention to this one because I saw one that looked pretty similar. Yeah, Mr. Maraji reckons we should do a locus one. Right, we'll see how we go. I will have to look up how to do locus. Remember, I'm only just staying ahead of you guys. I'm talking this coming Monday, Isaiah. So literally Monday the 30th. Because holidays doesn't really feel like it's the holidays, right? Right, we're going to do u divided by v. Let's write it all out first. 4k 3 cis 2 pi by 3 all over 3k squared cis pi by 5. Remember, the modulus, the number in front, just does the division just like normal. So we're going to have 4 by 3, and k3 over k squared is just going to leave us with k. So you could have 4k by 3 if you wanted, or 4 by 3k, doesn't really matter. Cis, and we're going to have 2 pi by 3 minus pi by 5. Oh, it's getting small, sorry. So let's type it into our calculator because I don't really like doing fractions. 2/3 minus 1/5, 7/15. So we're going to have 4 by 3k cis. What do we got? 7 pi by 15. Double check my answer. That's what I got. And we're good. Oh yeah, first half, second half. So did Tina go pi by 5 minus... Did you do it the other way around? Right. Last one, and then we're sort of done. And I want to talk about one more thing. But I told you today will be chill. You guys have worked really hard. And then we'll do De Moivre's theorem because I want to dedicate a whole sort of lesson on De Moivre's theorem. But I'll sort of introduce it a little bit today. Last example 5. I just read it wrong. That's cool. All good. 2 cis u equals 2 cis 2 pi by 3, and v equals 6 cis. I find this kind of like soothing because it's not very difficult. We want u over v, 2 cis 2 pi by 3 over 6 cis pi by 2, 1/3 cis 2/3 minus a half. I'm not prepared to do it today, sorry, Mr. Margie. I haven't done any work on it or anything. I'm not super familiar with De Moivre's theorem, so I'll have to spend the weekend just touching up, preparing everything, and then we'll do it on Monday. I did a lot of work yesterday on my year 11 stuff, so pi by 6. Happy with that? Margie Bits and collab. Yeah, we'll get him on a Discord call and we'll do a collab. Okay, now I'm going to introduce it briefly today, De Moivre's theorem, by looking at, so this is your homework, to just smash out a couple of these questions, right? This will be easy as, but I want to look at this question here, question 12, right? Because this is the beginnings of it, right? So let's look at question 12. Before I start it, just any last questions about what we've done? I'm hoping this is reasonably straightforward and we're happy with it. We're happy? We're good? We're good, we're good, we're good. Sweet. Right, let's have a look at this question 12. R cis theta all squared is the same thing as r squared cis 2 theta. And it's a proof question. Right? It was soothing. We good, we good, we good. Right. I was almost just going to give you this question. I was going to get rid of this part and just say calculate this. So let's sort of just do that, right? I'm just going to look at r cis theta all squared, right? Yeah, Miss Roger's saying let them try. I'm sure they can. I just want to go through this piece here, right? And then I'll give them a harder one to try. We know that we could expand this out, couldn't we? Right? We know we could expand this out because that's by definition what that is. And now you can see we're just doing the multiplication of two polar form complex numbers, And just like before, this is literally the definition of how to do this multiplication. Remember, we times the front, so we're going to get r times r cis theta plus theta, which obviously turns into r squared cis, not theta squared, 2 theta. Right? Can you see that okay? Right, that's meant to be the hardest question of this bunch. Reasonably straightforward. That is almost exactly de Moivre's theorem, except he generalizes it even further. Okay? I say my R is funny. Only when I'm doing R like this, because I find it, I don't know, I specifically say R differently when I'm doing it on here. The palmy accent. Let's look at this. So my de Moivre's theorem is not super up to date, but you can think about it like this. What if we had R cis theta all to the 4 this time? Oh, z cubed? Okay. I was gonna up the ante. Mr. Maraji's going easy on you. Okay? I want you to follow the same process as what I just did, but with this number, or with this complex number. Right? With this complex number. And you should notice something. I'll give you a little bit of time to start it, but you should notice something. What's tether? Theta, man, theta. There you go. Yeah, Rishi's onto it, and I'm sure the rest of us can get there too. You can see, if you want to do it all by hand, we can go like this. If you want to do the whole thing by hand, yeah, I'm with you, Maraji. That was my plan. We could do it like this. And we already know that this part turns into r squared cis 2 theta. So we're going to have this. And it's just going to be the same rule, isn't it? We're going to have r squared times r cis 2 theta plus another theta, which is going to be r to the 3 cis 3 theta. The power of r and the coefficient of theta is the power of the whole thing. Perfect. You are, Tina is officially de Moivre. I don't know exactly how to say his name. I think you kind of don't pronounce the V. De Moivre's theorem. Right? You just came up with the theorem yourself, which I think is great. This is why I love calculus, right? We always start with stuff we know. That seems real basic. You keep going through. We keep going through deeper and deeper, and we suddenly realize we've come up with a theorem, which I've done twice this year. Right? I've come up with my own theorems that I later find out is the conjugate root theorem, or yeah, I think it's the conjugate root theorem I discovered myself, and this one here. Right? So you can see that if we let z equal r cis theta, then z to the power of n, any number, is going to equal r to the n cis n theta. And that is de Moivre's theorem. That is de Moivre's theorem. And hence, any question that involves kind of powers, you could do at the drop of a hat. Right? Where, think about it like this, right? This is I'm making this up now, but imagine this situation. Imagine this. Z equals 3 plus 4i, my favorite complex number, right? And 3 plus 4i, and I said, can you please find z to the 8, right? That's going to be hell for you if you have to go 3 plus 4i times 3 plus 4i. Oh my lord. Hell no. I don't want to do that. Right? And this is the beautiful part of our transition between rectangular form and polar form. Right? We can convert this to our our polar form, and then this becomes really, 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 really easy. Right? So I'll leave that for you. Okay? I've made up this question. I don't know the answer, but I'll leave it for you. Right? Simplify this and give it a go. Right? But on Monday, because what Jimmy's saying is correct in chat, right? He said this isn't fully de Moivre's theorem just yet. He's right. There's a couple more layers to it, but on Monday we'll look at that second layer. But this is just a brief introduction where we have to understand this, that de Moivre's theorem comes from this multiplication, and that's why polar form exists. That's why it's so powerful. Isaiah says, oh, we have to put it in polar form first, 100%, because otherwise you'd have to do the huge thing. Do one example. Oh my lord, Mr. Miraji cracking the whip. Okay, Mr. Miraji, you want to give me an example, or should I just make one up? Let's say like 2 plus 5i maybe, right? And let's do z to the 4, let's say. Okay. The first thing we're going to do is we're going to convert it. So can we convert the 2 plus 5i? Do we remember how to do this? Raj ain't letting us up easy. Hell no. Oh, he's giving me the question even. 1 plus root 3i. Okay. So we're going to convert it. We could draw a diagram if we wanted. 1 root 3. So let's make this a bit bigger. 1, and we've got root 3. I'm doing the conversion super long. So we've got we know that the r, this piece here, is the square root of 1 squared plus root 3 squared, which is the square root of 4, which is 2. Happy. And then our angle here, theta, is the inverse tan of root 3 over 1, which we've done like 15 times already, right? Yeah, I know we've done it yesterday, sir. I know we've done it yesterday. Making sure we're all on board. So this equals, from memory, is it 60 or 45? I've got some 60s here. We can double check it. I trust Mr. Miraji. There you go. 60. You're all with me. And we're going to have r cis theta now becomes, which is, I better not miss my z equals, because Mr. Miraji will kill me, 2 cis 60. Right? We're doing our long conversion, which is a reminder of yesterday. And let's think back to the question. Now we've done our conversion. We want to find z to the 4 is then going to be r cis theta to the 4, which we know is really easy, and I'm going to wait for your answer in chat, please. Okay? Oh, not r cis theta. 2 cis 60. I want to wait for your answer, please. Got a couple answers in chat. Hannah's been lazy. Everyone's got the same answer. Just shift 16 their way through. So we're going to have 16 cis. What do you say? 240. And that was so much quicker. If the conversion took a while because we're going all the way back, right? Look, Mr. Murray's given us another example to do too. Right. I'm going to leave that example for them to do, sir. And I'll start with that on Monday. How's that sound? Right? Okay. Perfect. Alright, that's the real equals the imaginary part. I'll write down this question for you guys to do. Example 2. If z equals 1 over root 2 minus 1 over root 2I, find z to the 10, please. Right? Which Jimmy's already like halfway through the question. Do it now so they can do the exercise on De Moivre's theorem. Far, man. Right. What do we know about this situation, Jimmy? When we've got these two things are the same. Right? We've got a 1 over root 2 on our real and a minus 1 over root 2 on our imaginary. Yeah, you're right. So we can see that we've got a triangle. I'll make it bigger. A triangle with the sides the same. So the triangle with the sides the same, which means this angle is what? Alright, we've got some minus 45 degrees or minus pi by 4s. You're exactly correct. So therefore the argument is minus 45. And what is our modulus going to be? 1 over root 2 squared plus 1 over root 2 squared. Jeepers. Run out of room there. Let's tidy this up. What? Did you just see that disappear? It's all disappearing. No. It's all disappearing. There we go. Jeepers. Right. So with this, I'm going to type this all into my calculator because I don't want to do this. 1 over root 2. Or is it going to turn out into some nice power? That's going to be a half. There you go. So we're going to have, this is the square root of 1 because we've got half plus a half. I'll make your life easy. It disappeared again. You're just going to have to live with that. Square root of 1 is what, team? Square root of 1 is 1. So we now know, or let's make it z equals 1 cis, what was our angle? 45, right? Minus 45. Okay. And our question is z to the 10. equals 1 to the 10 cis minus 450. So let's think about minus 450, right? Minus 450 degrees is a lot of degrees. In fact, you'll loop around 360 and then come a little bit more, right? So let's have a think about this very quickly. This is minus 360. Sharp for doing our homework question, no worries. So that means we do another 90 this way, right? To do a total of 450. So we should write this as 1 cis minus 90. And Ms. Maraji is saying write the answer in rectangular form. So you've got to go backwards, right? Which by definition, 1 cos minus 90 plus I sine minus 90. Okay. Cos, I don't know my trig identities very well. That's a 0. Sine minus 90. That's a minus 1. So we have equals minus I. Tell me if I'm right, sir. Live mathematics right there. Doing your homework for you. But then I've got to find then we've got to find the homework. I don't have it on the on this computer, but I've got it on my little computer here. Yep, you're the man. There you go. You heard it from the man himself. So we're going to go 32.3. So we want section 1 of 32.3, is that right, sir? Section 1 of 32.3, I believe. There you go. So I will post this on my Google Classroom now. Section 1 of 32.3. Alright, Kate. It's like 10 questions. You'll get over it. Right? It'll put you in much better stead for Monday. Okay, thanks, Rebecca. For Monday, we're going over de Moivre's theorem in a lot more detail. Right? I have so many quizzes. Look, you should see this setup, Hannah. iPad, calculator, cell phone, laptop, dual screen, smartwatch, headphones, water, right? Sweet. We're going to leave it there. Alright, so just to reiterate what we covered today. Yeah, 32.3. I'll write it a nice big writing for you guys here. I'll actually post it on our Google Classroom though. Exercise 32.3, question 1, A all the way through to H, please. Okay? So, along with 32.2, you should do 32.3 as well. You got the whole weekend. Oh, which questions? I think those are the ones we eliminated there, I'm pretty sure. Oh, 6 and 7. There you go. Oh, we haven't even done 6 and 7 on 32.3. Oh, they can do all of 32.3. Is that what you're saying? Not question 6 or question 7. There you go. Right? No question 6 or question 7. Right? It's a skateboard, Hannah. So I'll post another section here on the bottom. Right? But just a heads up. What we did today, we discussed complex, it looks like an iron board. Right? We discussed multiplying and dividing numbers in complex polar form. Did 6 questions really easy, or 5 questions really easy. And then we did an intro into de Moivre's theorem that was a little bit chaotic because we were a bit off the cuff. But it's basically the same knowledge as multiplying and dividing. Right? With that, you will be equipped to do all of 32.2 except for these two, and all of 32.3 except for those two. Right? So that means today, do this. Tomorrow, do this. Sunday, have a break. Monday, come prepared for de Moivre's theorem. You've also got the 2 assignments to be doing in the background as well. So, if anything, this what do you call this isolation is a little hidden opportunity for you guys to work your asses off at calculus, isn't it? Right? And your other subjects your other teachers are nowhere near as invested as myself and Mr. Maraji in your learning, so you're sorted. Right, I'll ask again. So, do we have to do this homework, the common test, and the assignment? Right. This homework, yes, have to do it. Common test, yes, common test is really important you do it, but that's not due until the end of the holidays. And then the assignment, yes, truck away at that. I might even do a stream going over some of the answers there, or I'll do like a AMA of that assignment. Does that make sense? Cool. Rebecca's happy. Isaiah's happy. Just a quick lesson. Yeah. It was honestly, my plan was to be quick. My plan was to just get up to like just up to here. But then we did a couple other ones. Chemistry just sent through 17 hours. Well, that's ridiculous, right? Easy, right? Yeah, we just keep going, Isaiah. And I know you can too. Alright, Rebecca's spamming big brain. Awesome. Thanks you so much, guys. That's us. Right, 54 minutes. Or slightly less because we started like 2 minutes late. I know it's a lot of work. I know you can do it. Shot Rebecca. Yo! You can actually legitimately change the emote. That's so cool. I didn't realize you could do that. Okay. It's also a rainy day in Ruskell, which means what else are you going to do? Stay inside and do calculus, right? Isn't it? Fantastic. Right, enjoy the rest of your day. I'm going to go prepare for my year 11s. Right? Please be here on Monday, okay? Christina's here for the first time. Maybe you weren't, sorry. Okay. Yeah, make as many emojis as you want, dude. I'd love more. I just don't get around to doing it. Jimmy made this first one. Alright, but what I was going to say was, yeah, get a Mr. Maraji emoji. Please, please, please. Yes, this is what I was going to say. Thank you, Mr. Maraji. Spread the word about Monday, please. Right, Monday we're going to do de Moivre's theorem, and Tuesday, if I'm feeling up to it, Mr. Maraji will probably peer brush me into doing a locus theorem. Or not locus theorem, just locus. Okay, then we've done everything. Right, so please, please, please tell everyone. Hamza, put it on your Instagram story. Tell everyone that we're streaming Monday and Tuesday. Monday, 80% likely on Tuesday. Can you go over the skull count? Hell no. I'm not smart enough. Oh, someone got modded out. What did you say? Do I need to fix it? Is it I've got like some blacklisted words. I don't know how to get rid of them. Options. Oh, there we go. Um, there we go. I unblacklisted the Mr. and Mrs. Can Maraji go over Skull Cup? Probably. He's much smarter than I am. Yeah, same time Monday and Tuesday. Oh, he said assignment. Maybe it thought you were just doing the first three letters. Um, any streaming games? We'll see. I'll probably get bored in the break, but it won't be on this channel. Right, we're done. I'll hang around for like another 1 minute. Any more questions? But that's us. Yes, same time Monday, 11 o'clock. Monday, Tuesday. Let's do it. Please come. It's important for you guys. Remember, I'm putting in the effort. Please, please put in the effort. Cool beans. Let's call it. We're done. Enjoy your weekend. Enjoy the homework. Have a great one. And stay safe.